I can't say.
Who is that mate?
Okay, can you all see the slide?
Yes, madam.
All right, so let's see. So as I was saying, when you ingest a mature cyst, so through your food or water, then in the stomach, because of the pH, nothing happens to it over there. When it reaches the lower part of the ileum, then it uncoats itself. That's the S station. It's released, the cyst breaks, then the content is released. This content, what is that? This content, when released, will be made up of 8 trophozoites. 8 trophozoites. So the cyst has 8 trophozoites within. Now, these trophozoites are sent down by the process of peristalsis to the larger intestine. Please, if you know you have noise at your background, just mute your microphone. Now, once the trophozoites are released, they grow to maturity and then divide via binary fission. Now, once the division is done, that means they become so many over there, right? So the trophozoite has a protein that we call lectin. This lectin too is a virulence factor which helps them to adhere to the mucous lining of the intestine, and then it secretes enzymes. Now, if the parasite is able to move from the intestine to circulation, then it moves to other organs, so it gets disseminated. And in that case, when it reaches the other organs like the liver, the spleen, the disease presentation, then we call it extraintestinal disease, which simply means outside the intestine disease. So while it is within the intestine, the patient, it inhibits the absorption rates of the intestine. So the fluid balance over there will be interfered with. So by so doing, the patient will be presented with diarrhea, which we call dysentery. So in Entamoeba histolytica infection, you either present with the diarrhea or the same as the dysentery, or you present with extraintestinal diseases. In this case, what you're trying to say is that it has moved from the intestines to other organs. Now, as they are getting food, they continue to multiply. And then it will reach a time whereby there will be so many that they'll be competing for food. So once there is no much food coming, then some of them will start developing cysts around themselves. So this cyst would then be passed out. So when it is passed out, that is through feces, then another person can pick it, and then the circle continues. So this is what I'm talking about. The diagram is here. Let me use my mouse. So this is the cyst. The cyst. The cyst has trophozoites. So the cyst is in the food or in water. It simply means someone's feces in the food or water that you have taken in. And the emphasis here is mature cyst. So it moves straight to the GIT to the stomach. We say within the stomach, because of the pH, nothing happens. Then by the process of peristalsis, as it moves down, pH changes. Therefore, the cyst is able to burst out to release its contents. So from the beginning, you are seeing 4, right? Then, through binary fission, the contents will be released to give out 8 trophozoites. These 8 trophozoites individually divide into 2. So after the first division, the second one will be 16. Then the next one will be 32, like that. So they become so much in the larger intestine. What happens next? If they are there, you can present with dysentery or diarrhea. Then some can move out into blood, into circulation. So this,
Madam,
yes.
what's the difference between diarrhea and dysentery?
What's the difference between diarrhea and dysentery?
Yes.
Who will answer him? Who will answer Nat?
Dysentery is bloody.
Yeah.
Dysentery has blood in it, in the stool.
Yeah. And that is caused by the virulence of the lectin. You will see other virulence factors of E. histolytica. They even have ionophore-like structures that helps them to distort the ion channels. You will see that later. Okay. So as I was saying, it can get disseminated to other organs to cause the extra-intestinal diseases. So looking at examples of virulence factors that E. histolytica has, first one is the presence of the cyst around the trophozoites. The trophozoites also having the lectin. So the lectin is like the ligands that binds to the receptors within the intestinal walls. Then it also has the ionophore-like protein. So this breaks the ion channels. So potassium, sodium functions to maintain the fluid level will be disturbed. Then it also has some hydrolytic enzymes, the phosphatase, the proteinases, and then so on. All this will cause distraction, which will end up resulting to the death of cell that we are calling necrosis. It also releases toxins and then hemolysin. We saw the activities of the hemolysin in our previous presentation. Hemolysin, which implements is going to lyse the red cells. So that's the presence of the hemolysin will contribute to the bloody stool, which will be seen as a tool for diagnosis that we are terming a dysentery. Are we okay?
Yes, madam.
Okay. Okay, so I've explained this already. To brush through, the trophozoite adheres to the larger intestine, then releases its contents. Then by the contents being released, they also divide. Then the ionophore-like protein will cause the distortion of the channels. Then it will result to the leakage of ions to the cytoplasm, as I said. So the fluid balance will be disturbed. Then the enzymes that will be secreted will cause destruction of tissues. So it will result to ulcers. The presence of the hemolysin will cause the breakdown of the red cells that you'll be seeing in the stool as blood. So when we are infected with E. histolytica, you either present with asymptomatic infection or symptomatic infection. With the symptomatic one, it could be intestinal, which can be dysentery, or non-dysenteric colitis, then it could be outside. So they're also talking about other organs disseminated, which could be the liver or respiratory, right? Okay. So for the specimen for diagnosis is 2. Now, if you are suspecting dissemination or extraintestinal diseases, then you'll be looking out for biopsy from the liver. Then that is it. So for the stool, you'll be looking out for the presence of blood. And we are saying it is acidic in nature. Please, let's take note. In case I'm going to give you case study, I will use the presentation. So I can decide to describe the type of stool that the patient is passing out. So this should give you a clue to what type of organism that is responsible for this.
Madam, no problem, no problem.
Thank you. Let's move on. So you can do your
no problem. Who said no problem? Are you okay? Are you okay at all?
Nat, what's your problem?
Madam, continue your lectures, please.
So you can do your culture, but as usual, the golden standard is PCR, though it's expensive and not common. Then if you are looking out for the disseminated infections, then you'll be doing your imaging to see the structures of your organs involved. Now, it is a parasite. So in a parasitic infection, what type of white cell do we see in larger amounts? Parasitic infection. Bacteria, you see neutrophils. Parasite, you see what?
You see the same neutrophils.
The lab guy is quiet.
Madam, white blood cells. Oh.
Which type of the white blood cell? Is it eosinophils? Is it macrophages? Is it basophils? Is it?
Okay. It's not macrophages because macrophages will swallow, will engulf the this thing and swallow it. So I think it will not be. It will be neutrophils.
It's not neutrophils.
Someone said
Solomon.
Hello, madam.
Yeah, you are
Yeah,
right.
eosinophils.
Yes.
Basophils.
Madam, eosinophils and basophils.
Yes, you can see basophils.
Madam, eosinophils and basophils.
Yes, I've heard you. Thank you.
Repeat it again.
Eosinophils and basophils, madam.
Hey,
Yes, thank you. We've heard. Thank you.
No, basophils, not.
Repeat it again.
Please, let's take note of them. Bacterial infection, what you see, please. Bacterial infection, the type of white cell you see. So what are viruses?
Neutrophils.
Madam.
Viruses.
Madam.
Yes.
Monocyte.
Lymphocytes. T lymphocytes.
Yeah, you see T lymphocytes. You see some monocytes too. Okay. All right. So you can do. Okay, someone has sent a chat.
Lymphocyte. You don't see T lymphocyte. You see lymphocyte, not T lymphocyte.
You people. Okay. So if you can definitely, if the liver is infected with this particular protozoan, definitely it's going to get inflamed. So liver enzymes will be released. So this can also give you a gist. That is why I stated the liver function test and then the kidney function test too, as well, can be watch out. The treatment have some drugs.
Can the spleen too be?
Yes, the spleen too can be enlarged. Yes, the spleen too can be enlarged. Then our next condition is Leishmaniasis. Evans.
Leishmaniasis. Wait. Sounds like somebody's name.
Hello, ma'am. I'm not hearing anything. Am I the only person?
No.
I'm sure it's the network. I'm sure it's the network.
Go and ask your grandmother.
Hey, not. Hey.
I can say.
Oh, no.
It's Elisha. It's not.
People, you can talk, eh? Okay. So we are moving on to Leishmania. It belongs to the genus Leishmania. And then the species exists in two forms. Okay, so it exists in two forms. The amastigot, that means in this one it doesn't have flagella. The promastigot, which has flagella. So in this case, which of the forms will be the infective phase? Please unmute yourself and talk. The
flagellated.
The flagellated one.
Okay.
Because of the movement of the flagella.
Yes. Okay, someone to have sent a chat. Bismarck. Yeah, Bismarck, you are right. Okay. So they are transmitted by the help of a vector. This case, sandflies. So the name of the sandfly is there. So this is it. Beautiful sandfly is the one that carries. Is the one that carries Leishmania. So let's look at this diagram. Please, I don't think I can ask you to draw a diagram like this. Oh, okay. Okay, I can.
Hey.
No, not necessarily to draw, but to explain.
Madam, we beg. Madam, online, online or teaching, we beg.
Please listen. I said I can't ask you to go and draw human beings, sandfly, and all this things. No, but I can ask you to explain. Just like how I'm going to explain to you. You know, normally when I'm explaining the diagram, I don't talk about everything. I just give you a summary. I give you the salient points, right? So when you're writing, I also expect those salient points from your writer. Now, as we all agree that the infective stage is the promastigotes, right? So we have our beautiful, okay, some people have sent chats. Bismarck, you are not in normal times. Solomon, you think you can copy and paste for me, eh? Don't have an idea. Okay. So we have your sandfly having the promastigote coming for blood meal. So by that process, injecting the promastigote. Now, inflammatory response. So the first set to be recruited will be neutrophils. Neutrophils will come to try to engulf and digest, but they can't do much. So the next cell will be recruited, which is the macrophages. Macrophages, because they are large, they come and then engulf. However, they don't destroy the parasite, but rather they serve as a home for growth of the particular of the promastigote. So within the macrophage, instead of the body was sending the macrophages there to go and then defend the body, but rather they provide a conducive environment for the promastigote to be transformed into a mastigote. That means it's going to lose its flagella. Now, the amastigote phase is the diagnostic stage. Please, let's mastigote. Then the diagnostic phase or stage is the amastigote. So if you take the blood sample of anybody at all, and then you look out for macrophages, then and you're expecting infection of Leishmania, it's expected that you go straight to the macrophages and then you see the presence of a mastigote in there. Now, within the macrophages, there is division. These two, as well as the diagnostic phase, there is division ongoing. Then another sandfly coming for blood meal.
You have to relocate.
I'm drinking water, so I've muted myself.
Oh wow, sorry, madam. Drink all, drink all. We are waiting.
Don't worry. Okay. So another fly comes for blood meal and then picks the amastigote. Then within the guts of the sandfly, the amastigote gets its flagella back. So that will transform back to the promastigote, which then becomes the infective stage once again. Are we getting it? First one, infective stage, promastigote within the sandfly will be injected to man when the sandfly is taking meal, blood meal. First cells to be recruited will be neutrophils, but they can't handle it. So macrophages will come, parasites will invade the macrophages, then they will lose their flagella. By then, they are now a mastigote. Then they divide, they multiply, they become so much. Then, so now the human being is a carrier. So any other sandfly coming for blood meal, the blood meal will have the macrophages. This macrophages has the promastigotes, the amastigotes in. So they pick the amastigotes out once again, and then within them, they are transformed to promastigotes once again for the cycle to continue. Hope I'm clear.
Yes, madam.
Okay, now let's move to business. This is what we are interested in. So on the basis of disease presentation, they are classified into three. We have the visceral leishmaniasis, cutaneous leishmaniasis, and then mucocutaneous leishmaniasis. Please, let's take notes of them. I love leishmaniasis. I don't know where.
In addition to rotavirus.
You know, leishmaniasis is one of the tropical diseases that people have forgotten about, but they exist.
Now, which parts of the world do they exist?
Any forest
Africa in
zone,
particular.
yes, any forest zone in Africa. So even Axim, even some part of Volta region, northern part of Volta region, where they have thick forests. It is there.
Oh, okay.
Now, taking a visceral leishmaniasis, the etiological agent here, to be specific, is Leishmania donovani. So Africans, we call it donovani. Americans, they call it Leishmania infantum or Leishmania chagassi. Right? So the natural habitat for the Leishmania donovani is man, and then it has affinity for fresh red cells. No, immature, the fresh one, catch them young and they shall be yours forever, right?
Yes.
So donovani has a lot of affinity for the fresh succulent cells, red cells. So that should give you the first signal that if you're infected with this particular parasite, you will be presented with what?
You'll be presented with anemia.
Anemia. One of the clinical symptoms will be anemia. Okay. Okay. So in visceral leishmaniasis too, the liver and the spleen, as well as the bone marrow, where the cells are produced, they are mostly impacted. The liver and the spleen, because of the macrophages, right? So in this case, we're seeing enlargement of the liver and the spleen. Okay. So the presentation will be anemia, leukopenia. So leukopenia. Then the thrombocytes. So there will be a decrease. Okay. Talking about the white cells, you can't do without platelets. So if the platelets are in smaller concentration, you are predisposed to bleeding, right? So as I've said, to the spleen and the liver too are markedly enlarged. So you'll be seeing hepatomegaly and then splenomegaly as a complication. Am I right?
You are right, madam.
Okay. Okay. So we've already talked about, okay, so with the symptoms, fever as usual because of inflammatory response. You will see rise in temperature, then weaknesses due to the anemia, and then you are likely to see some diarrhea as well. Okay. Okay, so let's take note of this. The physical appearance that will give you the gist that it is visceral leishmaniasis is the presence of granulomatous lesion of the skin. So there is a formation of
How
reddish.
is it like, madam? The granulomatous lesion of the skin. Can you give a
granulomatous, brother?
What's the meaning of granulomatous?
Granulomatous.
Granules.
Yeah, madam. Granules.
Where are they?
Madam, it looks like granules.
Yes.
What are granules?
That is my question. Where do you find granules?
They are grainy, like sandy.
I said Gary, no Gary.
Nat, are you answered?
No, please.
Like
I
sand.
did not hear you.
Like sand.
Like sand.
Yes.
Oh, okay. Madam, continue.
Yes.
Okay. So if you
what
are seeing this,
present like gravels? Is it okay? The bigger ones, we do the same thing.
Now you have to find the name. Now it's all Leishmaniasis. Maybe it is not
okay.
Please, this condition, the granulomatous lesion, is what we are calling post-color exodermal. Post-color exodermal leishmaniasis. Let's take note. If leishmaniasis, visceral leishmaniasis, if it's not treated, it can result to death. There are other types of leishmaniasis that can resolve. For example, the cutaneous can resolve by itself, but with the visceral, because of the affinity to the red cells, the anemia. So if you don't treat it, definitely it could result to death. Right?
Okay.
Okay.
This small thing.
To you it's small. Let's try it and see. I'll send you to the place and then you'll get it and you see if it is small or it's not small.
Madam, let's try nuts. So I can observe.
You try me for what? Huh? Try me for what?
Leishmaniasis.
No. Let's try this thing. Cola. Cola. Yes.
He just got married.
A married boy. Yes, he should get married. The wife is even tired of the marriage already.
Okay. So in terms of immunity, we have both the cellular, whole cellular, and then the humoral in place. So the first one, we have the innate responding because of the bite. Then the humoral production of antibodies comes to play. Laboratory PCR is the gold standard. You can look at for others. Then in terms of treatment too.
Madam.
Yes.
Madam.
Yes.
You see the slide 192. You said it can cause anemia with the other one. It's also red blood cells production.
Your line is breaking.
Okay, I was saying that you said it can it can cause anemia and reduction in the production of the red blood cells, right? So my question is, how does it?
The reduction in the production of the red cells will result to anemia.
Okay, so my question is, you mentioned another name for it. Is it anemia and then one thing? You mentioned the name. I think it's on what on 192. Please, can you go back so that I see it?
He's there. Yes, you're there.
Okay, so my question is, madam, how does it interfere? Does it release toxins that interfere with the production of the red blood cells in the blood marrow or bone marrow? Sorry, or what is the mechanism behind it? What causes it?
Its presence there alone will elicit an inflammatory response.
Okay.
Right. So if the bone marrow is inflamed, there is no way it can perform its function.
Okay. So there's nothing like releasing of toxin or anything there.
Its activity at the end of the day will release toxins. All right.
Okay.
But even before the toxins are released, inflammation response. So that the inflamed bone marrow will result to inhibiting the rate at which the red cells will be produced. And then even the younger ones that are what is that? The parasite itself has affinity for the young red cells. So those small ones that we produce to the protozoan will try to invade and then lyse them.
Okay. Thank you.
You're welcome.
Madam, please, I learned they also eat on the red blood cell.
And that is what I'm saying.
Madam, you are the treatment. Let's do the treatment there. You've come to prevention. So let's do the treatment.
Okay, so the treatments are drugs of choice. Pardon?
Please, Christian is eating during the class.
People, your videos are on.
Oh, look at Christian. Christian is eating.
Hey, off your videos.
That is why Madam is not getting reception.
Madam, it has nothing. Madam, let's go. Video being on is not an issue, madam. We miss ourselves, so we want to see ourselves.
No. You can do that. You know, when we are done, I'll leave the meeting. You can see each other off your videos.
Madam, you have appetite for this food stuff here.
So I can't even see you because I'm sharing the slide, so I can't see you people. Okay. Okay.
Okay, madam, go on.
So prevention is for you to eliminate the vector involved. And then you do prompt treatment. Now moving on to the next one.
Madam, the treatment, I did not hear your line break, so please can you go over the treatment again?
Okay, the treatment, I have a lot of treatments. There are a lot of drugs over there that you can use. I don't mention them. There are lots of drugs of choice that I've stated here that you can use.
Drugs, okay. These drugs you've mentioned, okay.
Then with the prevention, the prevention you do with the sandfly, the vector, right? Are you clear, Nat?
No, madam. What I'm trying to, I was trying to ask a question. My question is, for the treatment regimes you've given here, or the treatments, different medications you've given here, please, if you can kindly outline the ones that how they attack the protozoans or whatever, so that we know what, because this is like a practical thing you're teaching us at once. So I will be very grateful if
your line is breaking.
Okay, madam, continue. I'll ask you later. Okay.
Oh. Okay, if you say so. So if we move on to the next one, which is cutaneous. This one, the etiological agents are 3. We have the first one, Leishmania tropica minor. So it causes the dry or urban cutaneous leishmaniasis. We have the major, which causes the wet or rural cutaneous leishmaniasis. Then we have the atopica. So let's take note of this. The reason why they are saying dry or urban simply means that the urban one, they are found in cities, right? Then the rural, the cutaneous, they are normally seen in the forest zones. Okay. So talking about cutaneous simply means the skin. Over here, infected sites are the ones in trouble. So once they bite, the endothelial cells of the capillaries around where the sandfly bites. And then the first presentation will be the nearby lymph nodes, right? We saw that at the site of injury, inflammatory response will really sit such that neutrophils and macrophages will be there. So original lymph nodes will be enlarged, right? Are you guys with me, or I'm talking in the air?
Madam, we are here.
Madam, we are here.
Okay. Then with time, it can get disseminated, so you see them moving.
And I think you have a chart.
I have a chart.
Someone has sent a question or something.
Okay. No, Solomon is